Hi everyone, this is your math guru. Today we're going to learn how to solve the following trigonometric identities. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have tan theta plus sec theta all squared equals 1 plus sine theta all over 1 minus sine theta. We have a left-hand side and a right-hand side. We're going to be proving from the more complex side, and in this example, the complex side is the left-hand side. So, simplifying our left-hand side, we have tan theta plus sec theta all squared. From our trig identities, tan theta equals sine theta over cos theta, and sec theta equals 1 over cos theta. We're going to replace tan theta and sec theta in our equation. We have sine theta over cos theta plus, replace sec theta, we change it to 1 over cos theta all squared. Because this fraction, they both have the same denominator, so applying the fraction rule, we put our terms under the same denominator, which is cos theta. At the top, we have sine theta plus 1 all squared. And if we expand our square, we have sine theta plus 1 over cos theta multiplied by sine theta plus 1 over cos theta. If we expand, or we open the brackets, at the top we are going to have sine theta plus 1 sine theta plus 1 all over cos squared theta. From our trig identities, cos squared theta equals 1 minus sine squared theta. We got that from cos squared theta plus sine squared theta equals to 1. So we're going to change a cos squared theta at the bottom. We still have a sine theta plus 1 at the top, sine theta plus sine theta, and sine theta plus 1 multiplying each other. We're going to change our cos squared theta at the bottom. That will give us 1 minus sine squared theta. 1 here, we change it to squared because 1 squared is also 1. We want to use the difference of two squares, which says a squared minus b squared. If we factorize, we have a plus b, a minus b. In this example, our a is sine theta and our a is 1 and our b is sine squared theta. So if we change that at the bottom, we still have a sine theta plus 1 multiplying sine theta plus 1 at the top. Difference of two squares at the bottom, we have 1 plus sine theta, 1 minus sine theta. This cancels. 1, we know that a plus b is the same as b plus a. So this cancels. We are left with 1 plus sine theta at the top, and at the bottom 1 minus sine theta, which is equal to our right hand side. So we've been able to prove the identity. Let's look at another example. In this example, on our right hand side, we have I'm going to change that. This is our left hand side. We have 1 plus cos theta over 1 minus cos theta. We're using x in this example. And on our right hand side, we have 1 over sine x plus 1 over tan x all squared. Like we did in the last example, we're going to prove in from the more complex side. And in this example, our right hand side is a more complex side. So we're going to simplify the right hand side and see if we'll be able to get the left hand side. So proving from our right hand side, we have 1 over sine x plus 1 over tan x all squared. From our trig identities, tan x equals sine x over cos x, and 1 over tan x will be cos x over sine x. So replacing that in the expression we have in bracket 1 over sine x plus cos x over sine x all squared. Because they have the same denominator, we're going to apply the fraction rule, which says If the denominators are the same and you're adding, you put the terms under the same denominator, which is sine x in this case, and at the top we have 1 plus cos x, adding the numerator all squared. If we expand, we're going to have 1 plus cos x over sine x multiplying the same terms, 1 plus cos x over sine x. If we expand, at the top we are going to have 1 plus cos x multiplying 1 plus cos x. At the bottom, sine x times sine x, that's sine squared x. Using the trig identities, sine squared x is the same as 1 minus cos squared x. And replacing that in the equation, we're going to have, this is equal to 1 plus cos x, 1 plus cos x, all over, we're going to change sine squared x to 1 minus cos squared x. We know that 1 is the same as 1 squared. So if we make this squared, using the difference of two squares, a squared minus b squared equals a plus b, a minus b. And in this example, our a is 1 and our b is cos x. So replacing that, we're going to have 1 plus cos x multiplying 1 plus cos x for our numerator, and our denominator, difference of two squares, we have 1 plus cos x, 1 minus cos x. This cancels. We are left with, at the top, 1 plus cos x, and at the bottom, 1 minus cos x, which is equal to our right hand side. So we've been able to prove the identity. Let's look at one more example. In this example, we have cos x over 1 plus sine x. In this, we are using alpha, not x, plus 1 plus sine alpha over cos alpha equals 2 sec alpha. We have a left hand side and a right hand side. Proving the identity, we're going to be proving the more complex side. And in this example, the left hand side is more complex. So we are going to be proving the left hand side to get the right hand side. So our left hand side have cos alpha over 1 plus sine alpha plus 1 plus sine alpha over cos alpha. Our LCD, or lowest common denominator, for this question is cos alpha times 1 plus sine alpha. So we have to make the denominator the same. And by doing that, we have on our left hand side, we're going to be multiplying with cos alpha in order to make the denominator the same. On our right hand side, we're multiplying with 1 plus sine alpha. Whatever we do at the top, we do at the bottom. That will give us, on our left hand side, we have, or our left term, cos squared alpha over cos alpha 1 plus sine alpha plus 1 plus sine alpha multiplying 1 plus sine alpha all over cos alpha 1 plus sine alpha. Now the denominators are the same. We can group them. Before we group, 1 plus sine alpha multiplying 1 plus sine alpha will give us 1 plus sine alpha plus sine alpha plus sine squared alpha. That will be 1 plus 2 sine alpha plus sine squared alpha. So I'm going to be replacing that in my expression. I have at the top cos squared alpha plus 1 plus 2 sine alpha, I'm expanding the bracket, plus sine squared alpha all over cos alpha in bracket 1 plus sine alpha. In our trig identities, we know that cos squared alpha plus sine squared alpha equals to 1. So we're going to be grouping cos squared alpha plus sine squared alpha. That will give us 1. So this is equal to, I'm going to put it here, 1 plus 1 plus 2 sine alpha over cos alpha in bracket 1 plus sine alpha. This will give us 2, so that's equal to 2 plus 2 sine alpha over cos alpha in bracket 1 plus sine alpha. If we factorize the top, I'm taking 2 out. I have 1 plus sine alpha over cos alpha 1 plus sine alpha. 1 plus sine alpha at the top, 1 plus sine alpha at the bottom. That cancels out. I have 2 over cos alpha. We know that from our trig identities, 1 over cos alpha equals to sec alpha. So putting that in our equation, this is going to be 2 sec alpha, which is equal to our right-hand side. Thanks for watching. Bye.